Hi, you're getting ready to do your first on your own. Let's look at data pattern sort. So let's sort of learn what I want, what I'm looking for, and how to do this assignment. Here's your Canvas page, and this is going to be a discussion assignment, and this is a group discussion. You've been put into groups for the first part of the semester. You're going to be working with the same people for the first 5 weeks or so. And so get to know each other. These are the same people you're going to be working with in the synchronous sessions until I switch up the groups around about week 6. In this, I'm asking you to look at some data and to write a post where you're going to make 3 different rules describing how charged particles relate to each other. Your rules are going to relate to the distance between the charges, the magnitude of the charges, and the sign of the charge. And your rules should compare experiments. When you're comparing the distance between 2 charges, I want you to pick experiments where you look at change in distance and control for all the other aspects. So control for the magnitude of the charge, control for sign of charges. Find 2 experiments or 3 experiments that you can compare to make a rule about how the force of attraction or repulsion exclusively relates to the distance. Same for magnitude. If you're writing a rule about magnitude, pick some experiments that really explicitly look at the magnitude of the charge and hold the other aspects constant as best you can. Here's the experimental data table. You're going to write a post with 3 different rules that cite experimental data that you use to develop your rules. You're not going to be able to see anyone's post until you yourself put your post up with your 3 rules. And after you post, I want you to comment on the person who posted right before you. So after you post, you're going to go look at the post that's right above yours and make a comment about any differences in the rules you wrote and their rules. So look for differences, look for similarities. If there's a disagreement, be very clear about, I think it should be this way. Don't attack and use the you. Use the I think. I saw this in the data. And neither of you have to be right. You're just looking for patterns and you're interpreting the data as you see it. At this point, this is just exploration. You don't have the right answer necessarily. You're just looking for patterns in the data, just like scientists do all the time. Here's the experimental data. You'll see an experiment number. So when you're citing the experiment, I want you to tell me which experiment numbers you're comparing. You see the charge of 2 different particles, the distance between them. And A stands for attraction, and R would be repulsion. And then here's the amount of force of that attraction or repulsion. So again, you're picking out experiments that will help you craft rules about how charged particles interact. Let me show you an example of what I mean by a rule for myself. What if I asked you to write a post describing the meaning of the plus or minus sign in that force of attraction? Well, here's the force of attraction part of the table. Here's all the experimental data. I want to pick out 2 experiments that are going to help me make a claim about what the sign of that force means, whether it's positive or negative. So when I'm looking for patterns, I'm going to look at all these numbers. Ooh, I don't want to drag and relate. I want to look for 2 numbers that are similar, that differ only by sign. So I'm just going to focus on this force of repulsion column and look for 2 experiments that only differ by the sign. And I'm looking at these 2 right here. This experiment number 3 has a negative 6.9. This experiment has a positive 6.9. They only differ by the sign. They have the same magnitude. Well, I'm going to go look at the other data in the table and see how they differ. Why might this one have a negative sign and this one have a positive sign? I'm going to go back through. I look at charges. For experiment 3, particle 1 has a positive 3 charge, particle 2 has a negative 3 charge. Particle 1 for experiment 4 has a negative 3 charge. For particle 2, both particle 2s have a negative charge. Both experiments have the same distance, but experiment 3 is an attractive interaction, and experiment 4 is a repulsion interaction. So when I'm trying to write a rule that explains this, I'm comparing experiments 3 and 4. Those are the ones that I've picked out to explain. How would I explain it? Experiments 3 and 4 have the same magnitude of force, which is 6.9 times 10 to the minus 10, or sorry, 10 to the minus 10, but differ in their sign. The negative sign, the negative 6.9, is associated with, and I'm going to go back up here, the negative 6.9 in experiment 3 is an attractive interaction. The positive sign in experiment 4 is a repulsion. Now, maybe I think that's just a fluke, and I want to look and see, is that general? Right now, my rule is saying that negative signs are associated with attraction, and positive signs are associated with repulsion. Okay, I'm going to look through and see if that's general. Negative attraction, negative attraction, negative attraction, negative attraction, negative attraction. I can't find an attractive that has a positive sign. Well, let's check out the repulsions. Positive, positive, positive. So I can say furthermore, all experiments with attraction have negative values. All experiments with repulsion have positive values. So I think negative force relates to an attraction or an attractive interaction between those particles. And a positive force relates to a repulsion. It's as simple as that. I want you to pick out experiments, compare them. Just look for patterns. You don't have to be right or wrong. The rubric doesn't relate to right or wrong. It just relates to looking for patterns and interpreting patterns that you see to make a claim about that. I hope you have fun with it. I hope you learn a lot in doing this. And at the start of next week's lecture, we're going to dive right into attractive particles. So this is really priming you for that lecture. Have fun.